Hi everyone. Today we're looking at calculating the volume of concrete to be ordered for the costing exercise plan. Now, at the top of your spreadsheet, put your project details and your student name. Fill in this part here with the details of what we're calculating. Our first calculation will be the rebate, which is this section here, the rebate around the edge of the slab. And what we do, we use the same process of A, B, C, D, E, and F. So this is what we'll do right now. We'll put in the sizes: 4.1, 3.2, 3.9, 6.8, 8, and 10. Then we'll put in our deduction, and our rebate is 150 millimeters wide and 170 millimeters deep, and we can get that from our RLs. All right, now A has a deduction of 150, B has no deduction. It's the same length as what we have here on the plan, 3.2. It's moved back a little bit, but it's moved back a little bit. Okay, so there's no deduction. So we have 3.2. C has no deduction as well. D has a deduction. E has a deduction. F has a deduction. And when we total all these figures together in this column, we get 35.4 meters of rebate around the edge of the slab. The next thing we do is calculate the rebate size, and I've said that the rebate is 150 millimeters wide and 170 millimeters deep. So here's our rebate section here, and that gives us a total of 0.026 square meters. Then we have to calculate the volume of that rebate. We take the length, which we've calculated, times the area of the rebate, and it gives us 0.920 meters cubed. The next thing we've got to calculate is the area of the slab. So we're going to break it up into two rectangles, area 1 and area 2, and then we'll enter the figures there, which this will be 4.1 by 10. By 120 millimeters thick, and that gives us 4.92 cubic meters. And area 2 is 3.9 by 6.8 by 120 millimeters, and that gives us an answer 3.182 cubic meters. Then what we have to do, we add the two areas together, which is what we've done here. Then we deduct our rebate, which was what we have here, and we get a total area, slab area, or slab component of 7.182 cubic meters. We then do the strip footing around which is the beam around the edge of the slab. We do the same thing. We enter in our A, B, C, D, E, F, and our width of our footing is 800 millimeters, so that will be our deduction of 800 mil. Then it will be the same process. B has no deduction. The internal corners have no deduction. You can see visually why the size doesn't alter. C is the same. D has an 800 millimeter deduction, as does E and F. And what that does, that gives us a total number of meters, 32.8 of edge beam around this slab, this section here. Then what we have to do to calculate the volume of the edge beam, we need the length times the sectional size. So we've got to calculate the beam section, which we'll just do this rectangular section to start with, and it is 800 by 0.47, and that gives us a total of 0.376 meters squared. Then we do the triangular section, which we determine, because this is the 200 millimeters. I'll just move that back. 200 millimeters by 200 millimeters. So the formula for a triangle is half the base times the height, which is what we do. And it will be 0.5 times 0.2 times 0.2, and that gives us 0.02 meters squared. And we add those two section sizes together. This one and this one gives us a section total of 0.396. Then to get the volume, we need to use the length, which we've calculated here, 32.8, times the sectional size, which is 0.396, and that gives us 12.99 cubic meters. The next thing we do is we add our sizes together for the total concrete, which is 7.182 plus our 12.99 times our 1.08, which is 8%. Refer to your calculation, the question, gives us 21.786 cubic meters. So then we come up to here, and in our costing sheet we put the unit rate, which is cubic meters. We then put the quantity in. We can't get 21.786, so we order 21.8, and that's it. Just try and keep organized, and good luck.